What's up, everyone? My name is Mr. H, and today we're going to answer a question. It's a simple question. Is there sound in space? So we see all these movies, explosions of Death Stars and stuff, and we hear the sound. Would that actually happen? I don't know. We're going to figure it out. First, we have to talk about what sound is, how we measure it, and then we're going to answer our question. So what is sound? Sound is the vibration of molecules inside of a fluid. Okay. So you're thinking fluid, you're thinking water, and good for you. Let's talk about water. So imagine a calm pool of water. The surface of that water is not moving whatsoever. Close your eyes. You have a droplet. You have a dropper, and you're going to drop one drop of water right in the center of the pool. Close your eyes. Think about what that's going to look like. It hits the surface area of the water. It creates a disturbance, and that disturbance goes outward all the way around. The farther you get away from the disturbance, the smaller the waves get. And that's kind of exactly how sound works. So we're going to stick with water. You're a whale. You're in the sea. You are communicating with another whale really far away. There's no other whales or fish around you. The water is super still. It's a calm day. No wind, no waves. Maybe it's the calmest day ever. Maybe it is the quietest the sea has ever been. Maybe the water molecules look like this. This is water molecules in a state of equilibrium. Equilibrium is when the molecules are the exact same distance away from each other. And this is where they're the happiest. They don't like being disturbed. So, now what happens? You make a whale sound, and the molecules that you're next to, they get disturbed, and that wave travels really far. I mean, whales can hear over miles. And you're a whale, you know that. I shouldn't even be telling you. Okay, so let's look at. Now there are two different types of sounds. There's unpitched sound and there's pitched sound. We're going to be talking about pitched sound. So pitched sound is where there's a regular pattern that reoccurs over a period of time. Unpitched sound is where it's an irregular pattern. So like if I clap my hands, if I play a cymbal, those are all unpitched sounds. But we're going to talk about pitched sounds. Whales are beautiful singers. So let's look at a sound here. All right, so we have areas where the molecules are close together. You see that? And then we have areas where the molecules are far apart. So what happens is there's a disturbance in the water, and the air molecules get really close. The water molecules get really close, and then they want to go back to equilibrium, but they overshoot it and they get farther apart. So those areas where they're closer together, that's called compression. And where they're farther apart, that's called rarefaction. And that happens fast. And when I say fast, I mean like hundreds, thousands, tens of thousands of times per second. So let's zoom in a little bit. Let's zoom into some of these water molecules. So they're in equilibrium. I want you to imagine that this axis here, this x-axis, that would be time, and the y-axis, that would be pressure. And we're going to talk about sound pressure. It's the sound pressure level. So right now, sound pressure level is 0 because there's no compression, there's no rarefaction. But let's disturb our water. We see there's areas of compression and rarefaction. And if we map it out over time, we see a wave. And this wave has a name, that shape. It's called a sine wave. And if that happens faster, the wave is faster. If that happens slower, the wave is slower. So one of the ways that we measure sound is in its frequency. That's how many times per second we go from compression to rarefaction back to where equilibrium would be, and that's frequency. And we measure it in hertz. So a hertz is one oscillation or one wave per second. The lowest we can hear is 20 hertz, and the highest we can hear is 20,000 hertz. So let's listen to 20 hertz. Here's 20 hertz. You probably can't hear it. You probably can't hear it because it's too low for your headphones to create. Maybe if you were at a concert, you'd be able to feel it. Maybe the subwoofers would make you feel it. But we're going to go up. We're going to bring this sine wave up, and now it starts to feel really low. And now it's getting a little higher. It's in the range of speech. Higher, higher, higher. Oh my gosh, higher. All right, so, and then the highest we can hear is 20,000 hertz. Now, for every doubling of frequency, we're going up a musical octave. So here's a note. This is A440. That means that we're vibrating 440 times per second. Now, if I go up and I multiply that number by 2, I get A880. Here's A880. And it sounds like the same pitch, but it's higher. And if I was to do that again, it would be another octave up. Or if I was to go down below, it would be 220, it would be an octave below. So that's how frequency works. So for every doubling of frequency, we are going up a musical octave. Now we also measure sound in amplitude, how loud something is, how much sound pressure we have. And the unit of measure we use for sound pressure is a decibel. So for every 10 decibels, it sounds 10 times as loud. So here we have a decibel chart, and we can see at the bottom, like the quietest sound in the world is 0. It doesn't exist. And like the loudest sound, like 140 decibels, that's like being right next to a jet plane. There is, a loud enough sound where you're going to actually feel pain, where you can lose your hearing, where you can black out. There is sounds that are loud enough where you could, be mortally wounded. But we measure the volume, the amplitude in sound pressure. If we're talking about waves, so like here is a wave. This is 440. And if I wanted to make that louder, I would just make the amplitude louder. So now I'm going to make it louder. I'm making the wave bigger. So it's like you dropped a bigger droplet of water into your pool. The ripples might be at the same speed, but they're bigger ripples. So let's go back to our question here. Is there sound in space? Well, we were talking about fluid and molecules in fluid, and there's no water in space. There's also no water around us right now because the fluid that we hear with is air. Air molecules are what moves around us. That's what makes the sound that we hear. And there's no air in space, so there's no sound in space.